everyone, so today we are going to look at two questions from chapter 8, 8.3 continuity. So the question gives us a graph. So based on the graph, determine limit x approaching a from the left fx, limit x approaching a from the right fx, and fa. Hence, explain why fx is or is not continuous at x equals to a. So the question gives us a equals to 0. At x equals to 0, fx equals to 0 is defined because 0 is a value. So next, limit x approaching 0 from the right fx equals to limit x approaching 0 from the left fx is equals to 1. So limit x approaching 0 fx exists. How do you get that? Let's look at the graph. So x approaching 0 from the left, you can see y is equals to 1. And then x is approaching 0 from the right, you can see y is also 1. And that is why limit x approaching 0 from the right and limit x approaching 0 from the left fx is equals to 1. Therefore, limit x approaching 0 fx exists. So the third one, f0 equals to limit x approaching 0 fx equals to 1. So therefore, fx is continuous at x equals to 1. Now let's look at the second example. If you're given this type of question, you have to make a number line. So let's look at the first question. A, find the value of A if f is continuous at x equal to 2. So at x equals to 2, you need to look at x equals to 2. So we need to make limit x approaching 2 from the right is equal to x approaching 2 from the left. So limit x approaching 2 from the right, 2 plus x equals to limit x approaching 2 from the left, ax minus 2. So when you substitute 2, you will get 2 plus 2 equals to a times 2 square minus 2. So 4 equals to 4a minus 2. 4a equals to 6 and a equals to 3 over 2. So a equals to 3 over 2. That is your final answer. Now let's look at question B. Determine whether fx is continuous or not at x equals to 3. So just like question A, we need to look at x approaching 3. So x approaching 3 from the left equal to x approaching 3 from the right. So 2 plus x and 3 minus x. So let's look at the answer. So if you want to know if it's continuous or not, you need to follow the three step. First, f3 equals to limit x approaching 3. 3 minus x equals to substitute. 3 minus 3 equals to 0. So f3 is defined. And then step 2, make sure it exists. So limit x approaching 3 from the right, 3 minus x, substitute. So equals to 3 minus 3 equals to 0. And then limit x approaching 3 from the left, 2 plus x equals to 2 plus 3 equals to 5. So it's not the same. So therefore, limit x approaching 3 from the right, fx, does not equal to limit x approaching 3 from the left, fx. So limit x approaching 3, fx does not exist. So number 3, we make a conclusion. f3 doesn't equal to limit x approaching 3. So fx is not continuous at x equals to 3. So that is your final answer.